Alright guys, learning target 10.1, as I've talked about a little bit already. This is I call it the probability chapter, okay? Before you can do probability, you have to know the total number of outcomes there are to choose from, basically. Okay, you need to know the total number of outcomes. And it's not as simple as rolling a dice, okay? Yeah, there's 6 outcomes on a dice, alright? That's easy to figure out. It's not as simple as drawing one card from a deck of cards. Okay, yeah, there's 52 total cards in a deck. There are more complicated ways and more complicated events that we'll be doing where figuring the total number of outcomes out is a little more difficult than just flat out knowing how many total outcomes there are. Okay, so what we'll use here in the first part of this chapter is we will use combinations and permutations, and you guys have done those before if you had me for Algebra 1. Okay. We're going to use combinations and permutations to determine the number of possible outcomes. So notice we're not even really doing probability yet. We're just using combinations and permutations to figure out how many total outcomes there are. Okay? So you can see the assignment here. It's on the calendar, page 686, 1 through 55 odd. They go really fast. Most of them it's just all calculator work, just a few multiplications and you're done. So it looks like a lot of problems, but this will take you less time than anything in Chapter 8 did. 62, 64, 65, 66, or excuse me, 68, 69, and 70. So those are your first set of practice problems for Learning Target 10.1. So just make sure you're kind of keeping up on that as we go, and I'm going to check you off too as with our new policy. So anyway, that is what we're doing. We're using combinations and permutations to determine the number of possible outcomes. So as long as this works here. Alright, I'm going to start pretty simple. Most of you guys have seen problems like this before. Right? My very boring wardrobe, as you know, pretty much consists of tennis shoes, pants, and polo shirts. Okay? I don't dress up too much. I don't like to anyway. And so let's say, alright, I have a few more than 6, but that's really everything else about true. Let's say I go to the closet in the morning and I need to decide what I'm going to wear. Okay? I got 4 pairs of pants. I got 6 different polo shirts. And I got 2 pairs of tennis shoes. Okay? My white ones are my Hawkeye ones. Okay? That's pretty much what it all comes down to. And I decide what I'm going to wear that day. Okay? And I could care less whether it matches or not. Okay? Obviously. Yeah. Alright? And what my question to you is going to be, how many total different outfits, if you want to call it that, okay? How many total outfits or how many different ways could I potentially dress on a given day if this is what I have to choose from? 48 I'm hearing. How do you guys come up with that number so fast?
6 times 4 is 24 times 2 is 48.
So you just multiplied them all together. Why did you multiply them together?
That's how you told us to do it in Algebra 1.
That's how I told you to do it in Algebra 1. Okay? Alright, good. Let me try to explain why that ends up working. Okay? Why you just take 4 times 6 times 2. Okay? Let's see this right up here. Alright, so here's me. Alright? Little stick figure there. My first thing that I need to decide, if I'm going to think about it in order, alright, I need to decide which pair of pants am I going to wear. So on this decision, I have 4 total outcomes. Pants 1, pants 2, pants 3, pants 4. Okay? I got to decide. I got 4 possibilities for that first decision I need to make. Okay, let's say I decide I'm wearing this set of pants. Well then, with that set of pants, I have 6 different polo shirts to choose from. So 1, 2, 3, 4, 5, 6. But I would also have 6 coming from this one, 6 coming from this one, 6 coming from this one. I just didn't draw them all out because I didn't want to use all the space on the board. Okay? That's a lot faster just to do the multiplying, like you said. Okay? And then, let's say I get down here, I chose 1, I chose B, well then I got 2 pairs of shoes to choose from. Shoes X or shoes Y. Well, if I would write this all out, if I had enough space to continue this tree diagram, how many things would I have at the very bottom of it? 48. There'd be 48 different things. There's 48 different outcomes. It could be pants 1, shirt A, shoes X. pants 1, shirt A, shoes Y. You get the idea. Pants 1, shirt B, shoes X, and so on. Okay? You'd have 48 different things at the very bottom of this tree diagram. Well, you're not going to want to draw out this tree diagram. You're not going to want to write every possible combination, try and figure out, well, he could wear his black pants with the blue shirt and the Hawkeye shoes. He could wear the black pants with the yellow shirt and the Hawkeye shoes. You know, you don't want to try and figure them all out, but you do want to know how many total outcomes there are. And so that's why it's a lot easier to just use the multiplication counting principle or multiply all of them together. But there'd be 4 choices for the first one, and then 6 on each of those, and then 2 on each of those. So 4 times 6 times 2 would help you get your answer here. Alright? A lot of times what I like to think of it is, here's my first choice. I got to decide on which pants I'm going to wear. I got 4 possibilities. There's my next choice for polo shirts. There's 6 of them. There's my next decision I need to make on my shoes. There's 2 of them. 4 times 6 times 2 equals 48 so-called outfits. Okay? Does this make sense? Okay? There are 48 different combinations or groups of outfits that I could wear. So actually I could make it through the year. It wouldn't look like I was wearing the same clothes all the time, because actually with this many clothes I could go 48 days and wear something different every day.
What it looks like together is a real question.
Well, you know, for some people don't worry about that.
If they're all blue shirts.
And a lot of them are. So,
Not when you're Hawkeye shoes.
yeah. Alright, so anyway, questions on this? Make sense? Okay. What we just used was the fundamental counting principle. If you want to write this down, write it down. If you get it, if you understand why we multiply them together, alright, do it. But what the fundamental counting principle says, if one event can occur m ways, and another event can occur in ways, then both events can occur m times in ways. You just multiply the total number of ways each thing can happen together. Just like we did with the outfit. How many different ways could I have selected the pair of pants? 4. How many different ways could I have selected a shirt? 6. How many different ways could I have selected the shoes? 2. So how many different outfits, how many ways could I dress? 4 times 6 times 2. You multiply all those possibilities together. Okay? That's what the fundamental counting principle says.